Welcome to my channel. Continue with solution of differential equations, the natural response with different types of roots, repeated roots, imaginary roots, and complex roots of the characteristic equation. So let us take a problem with repeated roots. The problem is to find the natural response of the system d square y of t by dt square plus 2d by dt of y of t plus y of t is equal to x of t plus d by dt of x of t with initial conditions y of 0 is equal to 1 and d by dt of y of t at t is equal to 0 is equal to 1. The characteristic equation for this differential equation is replace d by dt of y of t by m and d square by dt square of y of t by m square and y of t by 1 and make the right hand side of the differential equation is equal to 0. So we get m square plus 2m plus 1 is equal to 0 as the characteristic equation, and solution of this characteristic equation we get as m is equal to minus 1 and minus 1. This is a quadratic equation which has two roots and both the roots are same, minus 1 and minus 1, indicating that the roots are real but repeating. So the natural response is of the form a constant into e to the power of minus t plus another constant multiplied by t e to the power of minus t. This is the nature of the natural response. To evaluate the constants c1 and c2, we substitute the initial conditions. Substituting the first initial condition y of 0 is equal to 1, we get on the left hand side y of t is 1 at t is equal to 0, and on the right hand side we get e to the power of minus 0 as 1. So we get c1 plus here t is 0, so the second term becomes 0. So we get the value of the constant c1 as equal to 1. To get the next constant, we differentiate the natural response in terms of the constants that we have obtained. dt of y of t is equal to minus c1 e to the power of minus t minus c2 t e to the power of minus t plus c2 into e to the power of minus t d by dt of t, which is c2 e to the power of minus t. Now we substitute the second the initial conditions, that is d by dt of y of t at t is equal to 0 as equal to 1. So substitute t is equal to 0 on the right hand side and the value of the d by dt of y of t on the left hand side. By doing so, we get 1 is equal to minus c1 plus c2, and this term goes to 0 because t is 0. So we have c2 is equal to 2. Now we have the two constants c1 as 1 and c2 as 2. So the natural response after substituting the constants is e to the power of minus t plus 2t e to the power of minus t, and simplifying e to the power of minus t into 1 plus 2t is the natural response of the system described by this differential equation, which has characteristic equation having repeated roots. Let us take a problem with imaginary root. So find the natural response of the system described by d square y of t by dt square plus 4 y of t is equal to 3 d by dt of x of t with initial conditions y of 0 is equal to minus 1 and d by dt of y of t at t is equal to 0 is equal to 1. So the characteristic equation for this differential equation is m square plus 4 is equal to 0 and the roots are plus or minus j2. So we see here that the roots are imaginary. So the natural response for imaginary roots is of the form a constant into cos of the imaginary part into t plus another constant into sine of the imaginary part into t, value of the imaginary part into t. So substitute the initial conditions. First initial condition y of 0 is equal to minus 1. Substituting that in this equation 1, we have y of 0 is minus 1. So on the left hand side we have minus 1, and on the right hand side when I put t is equal to 0, the second term goes to 0 and the first term means c1. So the value of c1 is minus 1. To get the next constant c2, differentiate this equation 1 once and then substitute the initial condition d by dt of y of t at t is equal to 0. So differentiating, we get minus C1 2C1 sine of 2t plus 2C2 cos of 2t. And when I put t is equal to 0 on the right hand side, the first term goes to 0 and the second term gives 2C2. And on the left hand side, the value of this d by dt y of t at t is equal to 0 is given as 1. So 1 is equal to 2C2, or C2 value is half. So substituting the constants in equation 1, we have the natural response given by minus cos of 2t plus half sine of 2t. So let us take an example which yields complex roots for the characteristic equation. So find the natural response of the system described by the differential equation d square y of t by dt square plus 2 d by dt of y of t plus 2 y of t is equal to d by dt of x of t, and the initial conditions are y of 0 is equal to 1 and d by dt of y of t at t is equal to 0 is equal to 0. So the characteristic equation is m square plus 2m plus 2 is equal to 0. So make the right hand side 0. So the roots we get for this are minus 1 plus or minus j1. So the roots are complex with real part is equal to minus 1 and imaginary part plus or minus 1. So real part sigma is minus 1 and imaginary part omega is plus or minus j1. So natural response is of the form e to the power of real part into t. Here the real part is minus 1. So e to the power of minus 1 into t whole multiplied by constant into cos of the imaginary part value into t plus c another constant into sine of imaginary part into t. So now the imaginary part is plus 1 and plus or minus 1. The value is 1. So this becomes c1 cos of t plus c2 sine of t. So substituting the first initial condition y of 0 is equal to 1 in equation 1, we get the value of c1 is equal to 1. Again, follow the same procedure, differentiate this equation 1 and then put the second initial condition. We get the value of the second constant C2 as equal to 1. So we have the natural response given by e to the power of minus t into cos t plus sin t, because both C1 and C2 values are 1. So thank you for watching. Stay tuned for more solved example, a general solved example on natural response in my next video. Don't forget to like, share and subscribe to my channel.